welcome everyone. Welcome everyone. Just want to give a brief introduction. So my name is Mariatta, and I'm one of the Python core developers. I come from Vancouver, Canada, and I work at Zapier, building web applications with Django. But in the past few years, I've contributed to open source, and I've built various web services with Aiohttp. I think it's a cool library that we all should know about. So that's why I wanted to give this tutorial. Just going to introduce my co-presenter, Andrew Svetlov.
Hi, I'm Andrew from Kyiv, Ukraine. I'm also a Python core developer, work mostly on Async I part of Python, and I'm an author of Aiohttp and current maintainer.
And to help today, I have two TAs, Stefan and... Do you want to introduce yourself? All right, yeah, they are, Stefan is Python core developer, and how do I...
Svetlov.
Sorry.
Svet is okay.
Yes, he's been building some GitHub bots together, and he uses Aiohttp, so we're all in good hands. Before I start, I just want to mention about these post-its. So the green ones, if you are going through, as we go through the tutorial and you're doing good, you finish the exercise, you can put that up, so I know that you're done. But if you have troubles, you can put out the red one, and one of us will look into it with you. So if you don't have one, I think we have them at the front there. All right, so let's talk about Aiohttp. What is Aiohttp? It is a web framework for Async I. If you're familiar with Django or Flask, this is another of that kind of framework. So what is, before I start again, I just want to make sure everybody have Python 3.7 installed. Yes? All right. And you have all the requirements installed. There is an update to the requirements file. A couple hours ago, you might need to reinstall. Sorry about that. And you can test if you have Python 3.7 by running this code. This portion down here, it's just a list of documentations that you might want to refer to, but we're not going to go through this into details, but it's there if you need them. And again, the URL of this is in the class notes. You can check them out. All right, now let's go back to Async I. What does it mean to be asynchronous? I just want to give a brief example just to get ourselves quickly familiarized with Async I, and then we can go into the web service, web framework. Suppose you have a long-running task and you need to run them multiple times. Traditionally, when you run Python code, you will start one task, wait for it to finish, and then run another task, right? And this is a small code example to demonstrate that. So suppose I have this task that can take time. I would have to run them one by one. And you can see the output. That's an extra one. The correct output is down here. You will see that start a task, finish, start another task, finish, and then start another task. And the total time, it takes a while. Now, how is Async I different? With Async I, you can, the different tasks will be started simultaneously and then finish at different times. So the total time it's shorter than if you are to run that synchronously. So I'm just going to show an example like how to get started with Async I/O. So suppose the user function will look like this. Time begin sleep time. Sorry. Awake. And you would run it like this, right? Say 2 seconds. And it's kind of small, but that's how it works. And if you have more than one, you would call it multiple times like this. It takes time, so I'm not going to run too many. So now how do we convert this into async I/O? So the first step is adding the async, just like that. Now this is called a coroutine, but you can't, the way you run it is not by just simply running the code. It does not work. It will complain like that is coroutine, was never awaited. This is not how you run it. So to run this, you have 3 options. One is by using async io.run, and then async io.run that. I'm just running it in here. What's my async.py? So that's the output. So now it's running. You see the code is being executed. So that is one way to execute the async coroutine. Another way to execute the coroutine is calling await, like that. Whoops. Right? That is the right way, but it will complain that await outside the function. That's still not right. So basically, you will need to do async IO. You will create another coroutine, run task. Something like that. This is just to show you how you would execute, like call another coroutine from another coroutine.
Mariatta, for
Yes.
correctness, you have to replace time sleep with
Oh,
await.
yes, that is right. Sorry. Async IO dot
Await.
time sleep, right? Yes, await. That is a coroutine.
Yes.
Thank you. So now it's running. So that's just a brief example. And it's not exciting. So the next one, this has a more complete example. You can take a look at that. Now, again, let's go back to Aiohttp. Now we know about async IO. It can help us save time. You can run things concurrently. But what can we do about it? What can we do with it? The web frameworks like Django and Flux, they do not support async IO. So if you need to use async IO with those web frameworks, you can't do that. So this is where you might need to use an async web framework like Aiohttp. And I want to give a brief example, like how you using AIO HTTP to do web scraping, because it seems like everybody wants to scrape data from the internet and use it and analyze. This is just a fun little example. Say I would like to scrape PEP 8010. First, I'll show you how it's done without AIO HTTP. Usually, you would use request library. Client.py, import request, and with request is easy. Request get, whoops. Is that it? Content. Client.py. So it's going and it's fetching data. It's straightforward. And now let's try to do this in AIO HTTP. Remember, we need to have a coroutine that does things. And the code to do that is so is AIO HTTP run app.
No. Just Async I run for client.
With AIO HTTP.
Yes.
Like this.
Mm-hmm.
Session, right?
Yes.
Client session. With
Async with, please. And square brackets to create a class. You need instance of client session.
I like it.
I mean just this one.
So it will look like this, JSON.get. So it looks similar, except you will need to have like coroutines to do that. Wait, URL. Oh, wait.
Text maybe. And text is a function, yes.
So that is it's not text.
What's going on? Please switch back. Await. No. That's fine. Return back. Await. Data text. It's okay, but get is also a coroutine. So need this one.
Thank you.
Welcome.
All right, so now we got the data. So that is AIO, that is fetching data with AIO HTTP. And let's go to the next sections. I showed, I provided some write-up here. You can take a look, but it shows similar to the previous example where fetching data one by one takes longer time compared to if you were doing this with AIO HTTP, where it would start downloading about at the same time, and then this short one will be completed first, and so on. So it takes much faster. So I think it's useful if you need to do web scraping or lots of long-running tasks like this. And the reason why Aiohttp is nice is because it provides the framework for both client and server, whereas with Django, it's mostly a framework for building a server. Usually you would use it with request library as well to fetch data. That's what we do at Zapier. So with Aiohttp, you get both, so it less dependencies to be installed. Yeah, any questions so far?
Let me add a couple
Yeah.
of words. The real difference is the real reason why do you want to use async server when you have pretty good libraries like Django, like Flask, whatever. It's a responsibility because if many users ask your server, and server should do some relative long tasks like go to another server, ask Facebook, GitHub for something. If your architecture is built on with microservices, you have many network communications. And with Django, you can do it for sure. But Django starts, I don't know, 30 workers for a node. It means that 30 parallel requests can be processed, and 31st is blocked. It's wait for a free node. In Async I, you can start tens of thousands, hundred thousands of parallel requests. And if one request processing is waiting for response from GitHub, another one, all other responses are working. It's fine. It also allows to avoid a very popular familiar problem when almost all your requests are proceeded very fast, but if one request per 10,000 is slow and load is high enough, you can quickly overload server. Server will be busy on processing that slow responses. It's not a case for async frameworks. And next reason, it's pretty interesting by the way, is a memory. Because in Django, you fork 30 processes. Typical web server consumes, I don't know, 300, 500 megabytes. So you very quickly go to memory limit. And you cannot fork 100 workers on the server if the server is not very powerful. In Aiohttp and in any async framework in general, you can use less workers to handle giant amount of requests. And a worker, when it processes hundreds, hundred thousands of requests, consumes a little more memory than processing one request. So your limit is still close to 300 or 500 megabytes. But you can run much more. You can process much more users with the same memory. If you have extra memory, leave it for Redis, for caching, for everything. It's better usage than just clone Python process in classic way. So this was the reasons.
That's great. Yeah, thank you for the explanation. Any questions so far? Yes. Yeah.
Looks like a question for me.
Yeah.
First, client session use Async I internal objects. So lifetime of session should be shorter, should be inside of lifetime of running loop. This is the reason why you cannot create session on import time. It's not a limitation of synchronic code. Technically, you can create a session inside a constructor, but you should create object with this constructor from asynchronous code. Violation this rule is, for example, on import time loop. Well, it doesn't exist, event loop, Python event loop, Asyncio event loop. If you ask for loop, Asyncio creates an instance if you are in the main thread, but if you call Asyncio run, Asyncio creates a new loop. So session is coupled with Asyncio loop inside. If you run another loop than was used on session creation, program just hangs, nothing happens. That's why I added such protection. Another question is, how many client sessions should you use? It's interesting. Client session is an abstraction which contains cookies, client cookies, and connection pool. So simultaneous requests for the same session from different Asyncio tasks reuse this loop. It's very handy feature because opening connection takes time. If you want to connect to Google, Python, or whatever, connection is not for free. And Aiohttp allows to not shut down connection just after getting a page. It keeps it active for a while and close only after some period. So using a session for several requests makes sense. How many sessions do you need? Maybe, and this is a suggestion, to start from using only one session. Or maybe you can manually split your outcoming requests to big groups, like those requests are for Facebook and those are for Google. Having two sessions, one for Facebook, one for Google, maybe makes sense. Maybe you don't need it. It's, again, depends. A session has a parameter like how many parallel connection it supports. Default value is not too big, it's about 100. because without additional steps, a limitation for amount of open sockets for a process is 1024. You can increase it, but it requires additional steps on server setup. So you should keep in mind also this one. Also, if you use session for scraping the whole internet, you probably get too many cookies. It can be also a problem. Session saves cookies inside. It keeps cookies that sent by server. If you use for everything and touch too many files, cookie storage can grow in memory. And again, maybe you need it, maybe not. Again, depends. But better to try from a single session for everything, if you can. And after that, add new ones. Or use a new session for any new request, but you know, it's not the fastest way to work with internet. It's not how TCP sockets like to communicate. So that's it.
Oops. Okay. So the next section, so that's brief introduction, and thank you, Andrew. I think this is the fun part, at least for me. Let's all start writing our own Aiohttp session and server. And I will start by showing different pieces of building up a server. But at the end of this, we have provided some kind of an exercise where we will be building a server where you can create blog posts, retrieve the blog posts, edit them, upload a file. So, and the full example, full working example is in this link, but maybe we'll go through, try to create one of these at the end of this section. So, all right, now we have the requirements. All right, a simple web server. Start by defining the request handler, server.py, and feel free to follow along or just watch. So this is a request handler. It's a coroutine. It accepts a request and then returns a hello world, just a text. And next, we need to create the application. So we created the Aiohttp web application, and we're telling it we're going to create the root URL, the slash URL, and that it will be whenever somebody hits the slash URL, we'll execute this handler coroutine. So we will see hello world. And then just run the app. Okay, so, and then just run it. Now server is running. We can open it in the browser, and you'll see hello world. I'll give people some time to just try along. Do you?
For zeros works on Linux, on macOS, as I see. But if I recall correctly, Windows does not resolve this address, but you can use localhost or 127.0.0.1.
Like this, 0.0.1. I got the same thing here. Just put out the green one if you're done, just so I know, have an idea how many people are trying it. Okay, that's easy. That's straightforward. Seems like you all got it. Next, that's fine. Right, the other way to define URLs. So when you define URLs, notice this is a list. So you can always, if you need another URL you want to create, you just add another URL and it will, and the order matters, right? We will process from top to bottom.
Yes, it matters when you start using variable URLs with placeholders for variables. Mariatta will show it right now.
So that is how you would create another URL. The other way to create URL is by adding decorators. So this is, if you're familiar with Flask, they have the same feature there, but not Django, I think, not Django. So like that, another. So instead of calling add routes, we just do routes here. Restart the server and run it. Hello world, another. There it is. So if you wanna try it out.
The difference from Flask is in Flask you create an application or blueprint first and then use application instance to add URLs by decoration. In Aiohttp we decide to use different way. Routes is basically a list with helper methods like get, you see. A list with additional methods to add objects to this list. And when you have a route table filled with your URLs, you should explicitly add it to application. The reason you can separate route tables, list of routes from application creation. You should not create an application on import time. You can do it from inside an async function. You can do it later, and for Async I, it's important because application is Async I object. It has a loop inside also, and the same reason as for session exists for application. Lifetime of application should be inside of lifetime of loop. So you have to create application from async code. Well, it's not 100% true. You see, in this example, we create an application early, but again, it's a good practice to use a function, initialization function for application creation. And probably we will deprecate this usage later. Who knows? And examples from our tutorial site demonstrates init app async function usage. So this is the recommended way.
Okay, I will just copy paste that. Right? Yep. Okay. Next, sometimes you want to have arguments and parameters to your URL. For example, having, say you want to have a username parameter in the URL, like dynamically, instead of hard coding the URL, you can use that like curly braces here. And it's the same way if you were to do this without the decorator. I like to use the decorator, so the code examples here are using the decorator. So let's try this. And to retrieve the value of this parameter, you will get it from the request, match info, and get the username. That's the variable here. So let's do that and try it out. And there you go. And you can type any name. So another way to parameterize URLs, if in the GET request you might want to have the GET parameters, like if you're familiar with the URL, this part of the URL, you can do that too, and then the code looks like this. Instead of the match info, you'll get rel URL query.get. Let's add that in. All right, so now this thing works page 1 or something like that. So that's a brief example. I'm sure you'll use it for more complicated situations. All right, any questions so far? All right, so far our server only handles GET requests, but you will probably need like post or put and all that. And you can definitely do that by simply changing, instead of GET, you will do post there. Actually, I will do it here. So now the grid user only accepts post requests. We cannot simply go through this URL on the browser anymore. You will need to use a client to fetch this resource. And you will probably want to retrieve the data from the post method. So you will call await request.post and get the data like that.
Nice question. Because in post you can send a huge HTTP payload. So you can send the 20 gigabyte files. Maybe it's too much, but megabytes is pretty common. You can send a picture from your cell phone, and reading it takes time. Maybe you want to get it instantly. Maybe you want to get it by chunks. One chunk by next to other, say reading only megabyte chunk, process it, and do next. In case of HTTP forms, HTML forms, you want also maybe to process it in stream order, not to load everything in memory like we have in post, but use more complex code and process field by field in sequence. All these reasons are for adding await here. Await is a sign of some I/O input-output operation. And how HTTP works. You can read a header which contains path and HTTP headers, and you are ready to start processing request. And next, you can read a body. So two different operations. The same in client. You do, remember client example. You do client head, await client get, get a response object back, and for getting a response content, you should use await response text or await response JSON or work with multi-part encoding, whatever, use streaming content. All these operations require additional input-output. And every input-output is awaitable. It's an asynchronous function. And we explicitly want to do it. Would be design decision to fetch the whole content of request before starting processing web handler. But it's obviously easy lead to memory leak. And if you want to do it in application code. If you want to have all requests in memory, we cannot forbid. But you do it on your own, not on our library. So this is the reason. Another question? Yep.
Are you able to stack methods? So for instance, if you're creating a REST API for users, can you sort of stack the handlers for get and post like you would in Flask, and you can check the request method?
Stack.
If I have in Flask, they have like SQL functions you can handle your get and your post.
This is what you're thinking about, right?
Or just how you handle that situation.
You see, just decorate twice. Register your handler twice.
And then is there a variable that we can check for what the current HTTP
Request has a method property. If you want, if your code is organized in this way, you can do it. Sometimes it's convenient, sometimes not, but you can.
approach you recommend for
It works pretty well.
This works.
Yeah.
And how do you retrieve the method from the request?
Request.method.
Method that will give you get or post.
Request is a relative big object with many methods and properties. You can open HTTP documentation for full description. Also, HTTP has a lot of narrative documents describing how to work in different cases, how to operate with it. This is a reference.
This is the documentation here.
Yes, and in quick start and advanced usage pages, we describe some request and response aspects and usages.
All right. Great. All right. Let's go back. Okay. Where were we? Okay, we were doing a post, and because we made this a post, we can no longer access it from the website like this. So you can try out your post request by doing the client, from the client. So basically, if you put in the add user, whoops, let's restart my server. Oh, I need to put before that, because the order matters.
Yes,
Yeah.
while Mariatta changes code, see why the order is important. Username coroutine for greeting user has a variable in URL, and it variable matches any text in URL path segment. So if you push add user after getting username, add user will never match, because its request will be swallowed by former handler. So if you have a variadic URL and just constant one, usually you have to put constant first. URLs in HTTP is a list logically, and it iterates hour and hour looking for first match, not for best, because there is no good definition for best matching. HTTP don't decide. You have a variable, you have a strict string, and if request URL matches to string, use this strict. No, no such complex logic. Just go from top to bottom and select the first match.
So I just want to give example like how you can do the post using the AIO HTTP client. So what I did it, I added the URL here, pointing to my local server, and passing in a JSON object, username, and that's because my add user
It's
is
not JSON technically, but it will be form, yes.
multi-part. Yeah. It's expecting the username here. So Yeah, and let's try that out. So I have my server running, and client.py. So I received the response from my server. So give that a try if you like. All right, the next example I want to show is returning a JSON instead of a plain text like that. And the only difference is just you replace the web response with JSON response. It's pretty simple and straightforward. So,
But internally, data are encoded completely differently, you know. JSON looks like Python dictionary, pretty close, and post data, it has two encoded forms, as if is ampersand and equal, like in parameters, query parameters in get, and another one is multi-part encoding. We will show you how it looks like in after next session. So,
right, so whoops, go back to my server, restart it. And the get JSON URL. What am I doing wrong?
did you use JSON
Yeah.
in URL? I think you in browser,
Oh.
not get, but
Oh.
just JSON.
Of course.
Yes.
Okay, now it returns a JSON. All right. Yes. To my code. Terminal. Yes. That's a get request. Yeah. Ah.
Well, looks weird. um, okay. When I started to write web framework, I learned a lot, and technically, Get can have a body. Maybe you're surprised, but it can. Also, delete can have a body. So I agree. Looks strange, but better to use post for this example. But yes, it's a pull request body.
All right. Maybe we should remove
No,
this to
no problem.
confuse people.
Later.
All right. What's the next one? Do you think you can give this next example?
Yes.
Or?
Let's use this laptop. In web application, usually you need to use a database or another long-living objects. And in Aiohttp, the best place for initializing and closing objects like the database connection is clean up context, let's call it signal. So you see, we have a init application. Okay, I'm not good in Mac, but at least pointer works. So we have an application, we add routes here, and we register a coroutine. Actually, it's asynchronous generator with yield inside to register to create a database connection. And we use asynchronous library for SQLite. Usually, in your real code, you want to use MySQL or Postgres or real big databases. But for tutorial, we choose SQLite because it's already present. It doesn't require installing a server on your laptop, and good enough for demonstration. So we connect to the SQLite database. This is file name where database live. Initialize the connection and store in application. Application works like a dictionary. It has square brackets or operator. So you can push everything what you want into application on initialization stage before your server are ready to serve requests on time of server starting. Then we have yield. Many Python libraries use this approach. So before yield is initialization part, after yield is finalizing. You can avoid closing database connection, but usually I want to be accurate. If you create a resource, please close it. So how this is how it looks like. There are different also ways to do it for sure, but you have good and recommended example here. And in a web handler, you see, you can get a database from requests config dict. We used db for storing in application, and we get the value back from request. And use standard db functions to execute some SQL query, get result, commit it, and so on, and return JSON. We have an example, full example here. Click and learn. It has methods for working with REST API, list posts, create new post, get detailed information about specific post by its number, delete it and update. Describing every method is really tedious, but you can learn it. And our database structure is here. We have integer post ID, title, post content, and owner and editor fields. We will use it these fields later in session part. The idea is owner is a person who creates a post, and editor is the last editor, last updater. Again, full example Up.
Yeah.
Yep. It's really not very long, but still sizable. And I recommend to learn it yourself, to briefly read this code. We make a database if doesn't exist. We use a DB path in the root of our repository to share the same database file between this section and next ones. And what else? Time for questions, maybe. Is everything clear? Yep.
Is the app.cleanup underscore CTX, does that act like a middleware or something?
No. This one. Middleware is a wrapper around request. When server handles request, it can execute the code before request handling and after it. But initDB is just a single function for establishing connection to database and closing it. It's called not for every request, but only once at server startup. And last part after yield is called on server shutdown.
How does that work exactly when you call yield? It just returns a
It works like context lib, context manager, decorator, you know. Maybe showing the code is too much, but let's go to standard Python documentation. There is a context lib standard library. Up. What's up? Yes, we are here. Well, I'll increase the size, not too much. And we have a context manager and example, yes, like this. You have a initialization part, then yield something, and finalization part. And you can use it with managed resource. It's very, very common way to organize code in Python. And Aiohttp use the same technique, but it yields nothing because returned object cannot be used by Aiohttp. You just create a connection and push it explicitly into application under your name. Well, what should I say also? How to make it work? Initialize, call a next function, then get an iterator, iterate asynchronously, iterate one time, and on shutdown, asynchronously iterate next step. That's it. Other question?
So how do you handle synchronous code? Because there are plenty of libraries that don't use Async I internally. So how do you actually run those synchronous libraries within Aiohttp?
A good question. At First, I suggest try to find Async I library. If it exists, maybe you want to use it. If not, Async I still can execute synchronous code in thread pool. Uh, Again, for image resizing, later we will have a demonstration how it works. But briefly, it looks like you say execute this function, this code with z arguments in a thread pool, and the call returns object which is awaitable. So you use result is equal await run in executor synchronous code. And when synchronous code result is ready, you get control flow back and can do it. Sometimes it works very well. Well, it works always. It doesn't fail. But yeah, using a synchronous request library this way is not very good choice if we have Aiohttp client. If you have asynchronous library, usually it performs better in asynchronous Async I world. But you have a backup plan anytime. Another question? Oh, okay, let's go to the next section.
The next section is client.
Client here. Yeah, sure. Server. And, oh, no, sorry. It's not a tutorial. This is our guy. And we have a client. So we have a REST server. REST is a programming API. Our server accepts JSON requests and return JSON responses back. It's for programmers, not for end users. We don't read their fancy pages with images, animation, whatever. So usually if you have a REST server, you want to have a REST client for it to work with. Client is a set of handy helper methods. So at first, we're working with simple blogging engine. We have a post entity. We send post to server and get post or list of posts back. We can use, for sure, dictionaries for post data, but I have several reasons against plain dictionaries. Mainly because a dictionary is not structured well. It can have any fields. You have no idea what fields are. It has no typing information for type checking. It's just everything. That's why we use post data class. Brief description. Data class is a class which is decorated with data class decorator. Frozen means post cannot be changed after creation. Post fields cannot be updated. It's immutable class. I'll prefer to use immutables if I can, especially for data classes. It has several fields and a method to print post content. Nothing really interesting. Client. So we have a client for our REST API. Client is initialized with URL to our server and username. Username is used for owner and editor fields. We save URL, you save user, and we create client session here. Raise for status true is a handy helper which raises an exception if returned status code of response returned by server is not in 200s area. 200, 201, whatever. If server returns 400 bad request or 403 forbidden, 404 not found, 500 server is in trouble. All these responses are converted into exceptions by Aiohttp. You should not check it yourself. We also have a close method. Usually, if you have some Async I object, you should close it sometimes. Again, you can avoid it, but it's not very good idea. So we have a client. Client has a close method, Aiohttp client. That's why we, in turn, add a close method to our client, not to our Aiohttp embedded object, but to our REST client, which closes embedded object. And this is an example for list method. To get a list of our posts. Type hint in here. The idea is pretty simple. Using our internal Aiohttp client session, make a request, return, get response back, convert this response into a list of post objects. Make URL is a helper function. It's private because usually nobody from outside want to use it. User code of your client calls list, get, update, whatever. Do not call make URL method. But what it does, it constructs a real URL used for this call. So let's assume our server is started on localhost 8080. To list our posts, we should call localhost 8080-API here. Idea is pretty simple. Also, sometimes you need to return headers, for example, authorization headers, sign your request, do different things. But we avoid this complexity. You get my idea how to make it more robust and satisfy your requirements. Usage. We have a client now, not HTTP client, but our client wrapper around the HTTP session. We initialize it with URL and username and use await client list to get posts and print them. It can be improved. People usually don't, I wanted to say don't like to use try finally, but real situation is even worse. Many people cannot use it properly. I personally made such mistakes several times, like pushing client inside a try and it's a programming error. So this statement is much more handy. For Async IO world, for asynchronous world, we have async with. The difference is in old good with statement, you cannot do asynchronous code in enter and exit dunder methods. But async with, oh, sorry, forgot to change this example to fix it. Async with can do it. So async with client, do everything on exit from this block, client will be closed. And I'm really sorry. Should be a enter and a exit to work with async with. It's a new asynchronous magic methods. They are, you see, async def. This code is used to enter the context, and async def a exit, sorry again, closes our client. So again, full client is much more complex. The beginning is pretty same. We have a post data class. We have a client with all required methods like get, delete, update, you know. But we want to provide not only a class, but command line interface, like sorry, give me a minute now. Python code client, yes, we are here. So we have a command line tool with POSIX standard command line interface with help, with whistles and bells. And we had it using click. So let me make a full example. Let's start a server. Yes, we have a server here, REST server, and the client, say, list. It's empty. Let's use create command from here. Create. What is create API? I should provide title and content. Content like this. Up. Sorry. Yes, should be text. Fill here. We created a post, then list says we have one post. What also get. Let's see the full information about a post. You can try delete and update on your own. What is the tricky part of it? Is integration of synchronous click. Click is awesome library. I love it almost, except some parts. But click is a synchronous one. So this is a standard click usage, like we have a base group for main command, and you have commands in named commands in group to get, create, and post everything. And I want to use asynchronous code from this command. So you use async def create to allow to call my client, REST client. It's achieved by this decorator, which, see, this decorator may be a little complex, but this is the idea. We provide a wrapper which runs our internal asynchronous function and return result back. Also, click has a context. Click context is a global object for click, and we can push into this context our own class. So in the root click command, we create a root object passing URL user here, and this root object from here has a asynchronous method, async context manager, like just context manager I showed you before from context lib from here, but Python has also async context manager. The same, but you can use await from async. So we have a helper which creates a client, returns it, and closes after the usage. And in our click command handlers, we use form async with client, do something, and go away. So that's it about client. Do you have questions? Do you need a time maybe to try yourself?
I'll just mention that there's a break at 3 o'clock, so we'll try this out on your own and then take the break at 3 o'clock and come back after 20 minutes.
Could you please explain again how this async context manager works and what does it do?
I can. Let me switch to code editor. I use Mariatta's laptop and sorry. Let me switch to my own, because I don't know how to type properly on Mac. I prefer Linux. Linux and Emacs. Does anybody use Emacs? Good. So never recall how to change font by command, but this is a problem. No, sorry, it takes too long. Let me use simple editor. And where is the font size here? Small to small. Properties. Preferences. Yes, here we are. And nope. Not default, but something really big. Enough, no? Yes, will do. Okay, so, you know, thank you, Steph. We want to use async with statement. As obj to do something. Let me save it as Python to enable colorizing. Yes, looks better. But still colorizing don't like async vault. I cannot solve it. So we have a class which has a init constructor just as placeholder. That's fine. And we need to implement async enter. Return self. And need to implement async exit. Exit. Self, well, x type, x value, x traceback. We don't need all of them, but do something. Closing. And it's async function, so we can use await, like awake async IO sleep. Just for example. It works pretty well, but you have to write a class. You have to split logic between a enter and a exit. And it's not very convenient if you want to quickly just initialize something, return control flow back to the caller, and close. So what can we do? We can write async function which do initialize part, then yield something like, well, to be more concrete, client is Aiohttp client session, then yield client, then use await client close. The problem is this function, it's generator, it's pretty readable, simple, but cannot be used with async with statement. Async with func does not work as client. We want to do something like resp is let's use canonical way. Async with client get URL as response and print response status. Our function has no a enter and a exit, but we can make a decorator. Decorator is really, it's pretty easy. Should I display it? Maybe not. Maybe yes. So it's projects. Just let me open Python context lib and go to async context manager definition. Not format well to this screen size. Context. There. Scroll down, scroll down, scroll down again. So basically, what do you need? You need to create this function object. We have function. We have a generator is a function. We should to get async iterator from it. It's a gen iter. Now we are ready to iterate our function. We should call first iteration await it a next here. It runs our asynchronous generator to first yield, and we get result here. So far, so good. And this part, these two lines, could be pushed inside a enter function. Next part is again it a next to execute await client close. Real code has a little more checks, for example, to make sure that our function has only one yield and finished after calling second a next part, but that's it. And everything is done by context lib, I think, context manager already in Python 3.7.
So it's basically a static sugar for our class and a enter a exit, but in form of the function.
Yes. Again, like Python had already synchronous context measure for many years. It good idea, people like it, and we created asynchronous context measure for it. Because class writing is not always fun. People like shortcut. Another question? Okay. So let's make a break. Break, maybe.
See you all in 20 minutes.
Okay. Guys. Yeah, ready. So let's go next. We have a REST server. REST server was chosen as the first example just because JSON is pretty easy format. But now we will go to another example with templates. So let me open our documentation, not there. Yes. So, rendering HTML, constructing HTML by string concatenation is boring, you know, and it's dangerous. Usually, people use so-called template engines. And the most famous one in Python world is Jinja 2. Oh, now should be better. Yeah. I'm trying to save your eyes. If you have no eyeglass, please avoid it. Jinja 2 has no knowledge about Aiohttp. And Aiohttp has no template engine embedded. But we provide third-party library. Well, it's third-party, but officially supported. I wrote it, I support it as well as HTTP. Why a separate library? Because decomposition is a good idea in general. Because by this, we check if HTTP is good and isolated enough to allow write, for this example, template engine integration without modifying Aiohttp code itself. So it serves it exists for several reasons. Install Jinja and HTTP Jinja libraries. And we have a simple server, and we have a folder for templates. Template in Jinja looks like HTML code with, you see, this part is for variable substitution. Also, Jinja has a syntax for more complex control flows like if blocks, for blocks, cycles, template inheritance, whatever. But now we have a simple template. Next, we should install our HTTP Jinja 2 plugin. Usually plugins are designed in this way. They have a setup method which accepts application itself and optional parameters. Parameters depend on used third party. Here we provide a loader, file system loader in this case, which says take a templates subfolder and look for templates in this folder. And our code, old good great user from very first snippets, is modified to render a template. Jinja is built in this way. You construct a dictionary, call it context. Dictionary keys are context variable names, and dictionary values are values. So you have a context, and you ask Jinja template to render it. This is a template name. You pass request and you pass a context, and get rendered result back. Let's see how it works. It should be here. Code 06 templates. Yes. Very good. Now open the link. Are you here? What? I'm sorry. Because maybe I have to type something. Yes. So you see, it renders my name here, and the result, the page is result of rendering example template, and substituted date and username. You see, date, what? It's interesting. Because I did not provide it. And username. Good. So let's add the user-facing part of the site for working with blocks. We have an API. Now we need something to show to user. Again, we need a page for list our posts, to create a new, to edit existing, to delete, to view detailed information, to, what did I miss? To update it. What also I want to mention, see, there are two different ways to use Aiohttp Jinja 2. It's an explicit functional call, render template with passing name, request, and context. And another option is use a decorator. And please note, order does matter. At first, you should apply a decorator, template decorator, and then apply routes get. Why? Because the web handler signature is changed. You see, in first case, we have a async function which accepts a request and returns a response object. But with the template decorator, we have a async function which accepts request as in previous example, but returns a dictionary of strings to any object. It returns a Jinja context, and decorator takes this context and generate templates. It's a success sugar. Nothing fancy, but it saves a couple of lines maybe. But both forms are alternatives, they do the same. So now it's time to work with our blocks. We have an index page which selects everything from database, build a context is called red in this example. In this code, it's a list of dictionaries, and we return this context to template. Template should render it. Index template is a little tricky. I use template inheritance here. Jinja template inheritance. You can read more on Jinja site itself about inheritance, but the idea is our index page extends base HTML. Base HTML is a little is below. It's HTML with two blocks. You see, one block for title and another block for content. And by inheritance, we substitute override blocks in inherited page. Why people do it? To set up site style in CSS, basic layout, whatever, in base template, and file this base template with real content, which depends on page to page by inherited page. So you see for loop. This is how for loop looks in Jinja, if you don't know. And we render posts here, like a reference hyperlink. So that's it. The same for editing, but well, editing is a little tricky. Let me see how it looks like. We have a template server. And we have a list of posts. Sorry for garbage in titles. I was not accurate when filing my test database. So it's a page rendered by Jinja. Looks pretty straightforward and no colorizing, no styling, but good. You got the idea. We have a page for showing a list of posts. Now I want to teach you how to edit the post. For editing, we need to do the following. We have to display an HTML form, file it with existing values, and well, let me just show you. We edit form. We have a title, new title. We have a content, fancy content. And when I press submit button, the form content will be sent to our server. So now we are on a page which displays a form. How it looks like, pretty easy. We have a get post dash edit path. We read a post from database by fetch post call and return it as a Jinja context and render this form. Template for form rendering is here. You see, this is a form. Action is a URL to send form data. We use method post, which is recommended way, by the way. Don't use get if you don't, if you're not sure. And encoding type is multi-part form data. We have several fields to edit, submit button, that's it. When I press submit, I send post request to server. Let me do it. Click, yes. We have, you see, updated title, and the database is updated as well. How is it proceeded? Post data is sent in this form. You see, it's a little complex encoding. There are two parts, first one and second one. This is separator between fields. If we will send an image content would be added to this text, and again in encoded format. The content could be very huge. Aiohttp know how to parse this data. So our post web handler reads post data, everything in memory, sorry, iterating field by field saves memory consumption, but I don't want to blow up this tutorial. Let's keep it as short as possible. So we have a new post data. We execute database query, SQL query to update title and text. Here we should commit our changes. This how this library works, and we don't render a new content immediately, but return a redirection response, and browser will go to this location, but with get methods. It's pretty common again in web development. Pretty common technique, which, well, let me skip the reason, but trust me, everybody should do it. Everybody should return a redirection after accepting form post data. So we have, again, several endpoints for getting a list of posts, for showing a new form, and accepting form data, applying to database. Show post, edit post, apply post data, delete post. No, please note, in REST, we are free to use delete, patch, and put HTTP methods. Browsers without JavaScript know only about get and post. So we need more endpoint to emulate it. And we need, you see, two web handlers for post editing again, for the same reason. One is for showing HTML form, and another one for applying form data. You see, this is a full function example. I hope everything works. I want to mention that we did not make good test coverage for this tutorial, and it scares me a little. Usually I do code with good unit testing, but well, for tutorial it gains out of scope. So maybe something will go wrong, but let's try. I test it manually. Text, submit. You see, new title, text, anonymous, because we need a sessions to implement login, logout technique. Text, new text. Submitted. In view, we see new one, and we can press delete. The post disappears. Maybe ergonomics is not very good, but it works, and you can improve it if you want. As usual, we have a full text for this example. Actually, looks pretty close to REST server code, but it does not return JSON, but render HTML pages. Well, Ginger templated page is finished. Questions? Oh,
HTTPC other, does it return a different status code?
the other is for 302, I guess. It's not 200. It's redirection code. If you open tutorial for Django for Flask, you will see code which looks pretty similar to this one, but without async await syntax. Any web framework on Python which works with templates, create a context, render it, accept forms, apply new data to database, and that's it. The next section is images. Our database actually have a image field in post SQL table with bytes type. It's a blob field. Usually, again, you want to store your images on CDN or on Amazon S3, whatever, not in database, but for sake of simplicity, for tutorial, database is good storage, good enough. How we handle images? we need yet another route, call it post dash image, where post is post number, to fetch image content from database and return a response with type, you see, image JPEG. Content is image content, just bytes of JPEG representation. If the form has no image, we quickly render black square for it, just to show something. We modify our template to display an image, just very easy EMG HTML tag with image source pointing on our image web handler. And that's it for displaying app. I don't see images here because I have to run another server from news section. Yes. So, yes, you see, here's a small image with something. Something is some text. Okay. This content is stored in database. To edit an image, we add a new field, you see, form field, which suggests to select a file and click submit button. The picture is changed. Sorry, I did not prepare pretty looking cats to upload, but you can do it. How to work with image uploading? Form is easy. The next step is a little more complex. Let's see, we have a form. We are getting an image from form, and if image exists, we apply it, save in database. Image does not exist if I don't choose a file, you see. So now I can change the title, but not image content. So title is changed, image is the same. And what also I want to show is really image size uploaded to server is pretty huge. It's pictures from of my document which I used just photo shot on from my cell phone. And I don't know how many megapixels, but the size is big. I want to resize pictures before saving in database. That's why I have another coroutine, apply image, which uses peel to resize image data. You see, we get construct a peel. Peel is Python image library famous Python image library. We have an image object. We resize it to smaller size using very powerful anti-aliasing method. Get new image and save in database a content of small image. And I use run in executor here. Run in executor is used for the following reason. Image resizing, especially resizing of huge image, takes time. It is a CPU heavy operation, so-called CPU bound operation. But in Async I/O world, you have to avoid such operation in your async functions, because resizing can take time, and on time of resizing, your server becomes not responsible. It does not serve another users. It is resizing the image. Everything hangs. It's bad. So Async I/O can apply CPU bound or synchronous operations, synchronous code to thread pool. So Async I/O has a thread pool by default, or you can create your own. And pool has several threads. By default, how many cores your system have? Four threads on my laptop, or eight, I guess eight. So laptop has 8 waiting threads. We apply a new job to the thread pool. In separate thread, image is resizing. We are awaiting it here. Awaiting means our server is switched to another coroutines and handle another request. It's not frozen. But when resizing is done, new image, result of resizing, is returned from the thread pool, and we can work with it again. Technically, maybe I can push under run in executor such calls like image open, image save, but it depends. Depends how many time is spent on these calls. I would say that opening image of unknown size uploaded by client may be worth to be pushed into thread pool. Saving small 64 per 64 image is pretty quick. We can do it in the main loop. You every time should decide, do you want to write more code to run in thread pool, or you believe that the operation is fast enough, don't block a loop, it's almost instant, so do it just in place. It's pretty common trade-off. So now we have an image. Yep.
Are there any recommended techniques for profiling or load testing to determine to see which code leads
Nice question. Do you see how I run the code? We have Python 7. We can use this option. It enables debug mode for Python, not only for Async I, but several useful debugging. See more output. And if the operation takes a lot, I don't know, can I reproduce it now or not, but let me try. Wow, it's an enclosed file, so bad. Still everything is very quick. But if a code between two awaits, if a code in async function blocks event loop for longer than 100 milliseconds by default, you will see debug output for it. It's a good sign of you have to put it. Usually you have to put this blocking code in executor. What?
Would the time that sleep do this? Like if you do not the async sleep, but the time that sleep?
It's blocking code.
Yeah, so you could then see.
Yeah, yes, if I will put sleep 1 second, I will see it here. You can try. If I will use regular requests library to get a page from Python org, I'll see a warning. I know. Reading a very big file from local file system is also blocking operation. Every call which takes long is a block. And asynchronous good, asynchronous code should avoid it. Python async IO debug is environment variable does the same, but -x dev easy to type, and I like this addition. Also, sorry, I missed a section called, no, missed nothing. Next section is middlewares. Middleware is a simple idea. It's a async function which accepts request and next handler in a handler's chain. So when you think about middlewares, you can imagine an onion with middleware inside, and our web handler in the core. So when request is processed, top level middleware is called, inner middleware or web handler is passed as handler. Middleware can do something before passing execution to inner handler, or it can, well, can do something, and can do something after getting response. Sounds very theoretically, but this is a useful example. If we get an unknown exception from our web handler, we render a special error page. Pretty easy. We should handle web HTTP exception because it can be redirection. We skip special Asyncio cancelled error for task cancellation. Let's don't speak about it too much here. But all unhandled exceptions are rendered by Ginger error page. How it works? Let's execute a code from middlewares and try to view non-existing post. Here, sorry, you cannot read it probably, but it's just a random big number. And you see post doesn't exist. I have an exception from inside machinery, and this exception text is rendered by special error page. Nothing hard. So we have a middleware, we have a Ginger template to render this text, you see. And we need to initialize to tell Aiohttp which middlewares are used. I forgot to put it in website, but the idea is here. We create an application with a list of applied middlewares. This is one way how to do it. And also you see client max size. It's because I upload really big pictures, and default Aiohttp limit doesn't allow such large image, and I want to increase it. Aiohttp tries to control memory consumption, to don't have too big memory footprint. What also middleware can do? It can modify request, actually clone it with different values. Request headers are immutable property. You cannot modify them in place, but you can clone a request with passing a new host remote and schema. It's useful if you push your server behind Nginx, for example, behind a reverse proxy. And to get a real user IP, you cannot use IP of peer, but should to get X forwarded for HTTP header. It's just how it works. But anyway, you get the idea. You clone a request with new value and pass into inner handler. You can wrap a handler and execute database transaction committing is if everything goes good. If something bad happens, if exception is caught, you can roll back database transaction. Maybe useful. You can check if user is logged in, and this is non-existing function, which let's assume it's get a request and somehow returns a user from request information. And if user exists, let's store it in the request. Request as an application is a dict-like object, by the way. But if request does not exist and handler is marked as it requires logged in user, doesn't work with anonymous, let's redirect to login page. Otherwise, work as usual. This is full example. Full example is for free reading. Next page. Next page is Aiohttp sessions. Sessions in this context is a storage to save user-related data. The storage is not huge usually, but you can save a username, some related information. Aiohttp has a Aiohttp session plugin library, which need to be set it up, and you pass a storage type to session. We use unencrypted, totally insecure, simple cookie storage in this example. There are encrypted cookie storage. Actually, we support 2 out of the box. You can set up a Redis as a session storage. Always the idea is partially, at least partially, data is stored in browser cookies. Browser cookie has about 8 kilobyte limits usually for single record, so you cannot save in cookie your picture. Or sometimes a cookie has a some identity key to search all the rest data, actual session data in database. What do you use? It's up to you. Session object is a dictionary with several additional properties, like is session new, is session saved, doesn't matter now. And we have a couple helpers. See, this is a decorator which marks a function that function requires login. Pretty simple. We have a middleware, like middleware from previous example, which at first determines is this protected web handler, protected endpoint or not. And if login is required, endpoint is protected, and user is not logged in, then redirect. Otherwise, pass control flow to our web handler. And the usage is for our protected endpoints, like we decided that anonymous users can see list of blog posts, can see particular post content, but cannot edit. To edit, you should log in. So endpoint for edit post is marked with require login decorator. We set up our middleware registered in application, check login middleware, and it's almost it. The last part, we have to handle login page, login and logout for completeness. So login, it's like simplified post-edit page. We render a form, we have a post route for this form, and save username into session. Let's see. Very easy. Logout is even simpler. For logout, we clean up our session username field. How it looks? Sessions, session, yes, here. So let's go to the root. It's helper, I'll describe it later. It shows that I am logged in. I have to log out. I can see posts, but I cannot edit. It cannot delete for sure. On login, I should type something. Adding password is really easy, but you know, it's out of scope again. Consider it like it's consider edit password as a separate exercise. So now we see that I am logged in and I can edit post. Replacing this ugly name with is just, I don't know, post. Yeah, and post. Everything good. The last need is Jinja has a context processor. Context processor is a way to add variables to run Jinja context, but not to file to get, in our example, username in any web handler. I mean, I can modify my code. This is index. I can say username is session, get session, about session username, and copy this line everywhere. Everywhere in here, new post, edit post, and you got my idea. But I don't want to do it. I'm a lazy guy. I want to use a base template to render here is user anonymous or not, and display login or log in or log out links. And I can do it automatically by providing a context which returns a part of context actually. It's a dictionary which is added to main context. And this async function which accepts request, returns context, partial context dict. I should set up it in Jinja middleware. Very handy. It's basically it's a Jinja built-in facility. I just added asynchronous version of it to asynchronous support to this feature. So we have now middleware sessions examples for them. We are almost done. So do you have questions? Yep.
I apologize if you maybe answered this during one of the breaks, but is there support for any type of ORMs?
I would say no. There are libraries for PV-ORM, Async PV called, and that's it maybe. For some libraries like Aiohttp, MySQL, you can use SQL alchemy notation to describe tables, not objects. There are no mappers, but table definition, and you can use this table definitions to make a query. It's much better than string concatenations. Full ORM is really hard and big piece of work. Famous SQL alchemy is not designed to be to allow asynchronous code injection. It's impossible to implement a dialect for SQL alchemy, asynchronous dialect. So current situation is you can do something, but not full-fledged ORM. And maybe it's not such bad because now we have 2019 relation databases are not dominant at all. Usually we have a complex heterogeneous systems with partially data in database, partially in Redis, partially it's somewhere else in, I don't know, key value storage, blob storage, whatever. Data are denormalized, so reason for a good ORM not disappears, but becomes much lower than 10 years ago.
That brings me to the next question is there any support just like simple support for some of the non-relational like Mongo or Elasticsearch?
There are async libraries for both Mongo and Elastic. You just use Google and find something. Yep.
It's related to the template. What if we have static resource like CSS? How do we store?
Well, good question. Aiohttp can serve static files. You can just say application router add static and point on directory to serve. But usually you deploy application behind reverse proxy, behind Nginx, behind Amazon Elastic Load Balancer, behind something. This front-end server usually is a better place for static file handling.
So we should not, or
They can. But guys, Nginx serve static files faster. HTTP still can do it pretty well. But it's not a competitor with very highly optimized C code, optimized for serving static files as well. Python is not the fastest language in the world. So I recommend splitting responsibilities. If you need some code, some logic, that's why you use Python, not C. That's why you might use HTTP. But the same rule is for Django, for Flask. Nothing new in Async world. Nothing new in Async I. And like Django can handle, or Flask can handle static files, HTTP can do it too. So, do we have time or not?
We have about 15 minutes.
15, okay. I want very briefly to tell about how to test. Testing of asynchronous code is pretty similar to standard synchronous one, but tests are asynchronous functions as well. I don't want to tell about standard unit test because it's possible to do in unit test with third-party library, but I prefer PyTest approach. And what should you do? You have to install PyTest Aiohttp plugin to PyTest. And please note, PyTest HTTP unfortunately is not compatible with PyTest Async I, and it's a long story. Why? With PyTest HTTP, you can write PyTest style test, not like just dev test, but async dev. And plugin will handle it automatically. If the plugin see the test function is asynchronous, it creates a loop instance per test function run to make isolated environments to get test isolation and execute it. Looks pretty easy. Internally, it's a little tricky, but it doesn't matter. To test our application, we need to modify it a little. See, I pass db pass to database to our code. And by this, we can use one database for, let's call it production, and another one for testing. And I can use, can create a feature to create a database in some temporary location, create a database every time, a fresh database for new test. Again, to separate test. If I want, I can share database as well, sure. So I have a feature for database creation. I have another feature, asynchronous feature. See, you can use await in features to connect to database, to get a handle, to have connection to access database. Then we need a feature to make a test client. HTTP provides built-in features that creates test client. What does it mean? We have an initialized application. We pass it into HTTP client, and HTTP client, it's a special test feature, finds a free port on local host, executes server on this port, waits for test finishing and shut down everything. Basically, we can recreate a server instance, unique new server instance per test. And it works amazingly fast and very, very handy. So we have a test client. It's like client session, but works with ephemeral server started on random port. And we test our API. You see, have a response, check code, check JSON content. By default, after creation, database is empty. We can save something into database not by using our REST API, but directly pushing data into database, and then use HTTP client to check how our REST API works. By this, we can test everything on our server. If you want to test how template rendering works, just ask not API post, but post views, another endpoint, and get response text and see how it looks like. Just like regular tests. Client. Remember, we have a client also from section 5. REST client. If you have a code for server, it's pretty easy. Let's use another HTTP toolkit feature. Here we used HTTP client to get test client section. Now we have a HTTP server to start server again on random port. Actually, HTTP client feature uses HTTP server feature internally. And we have a server instance on random port. We have a URL, server make URL, returns a root endpoint with host and port. Host is actually a local host with proper port for started server. And we can just pass this URL, test user, get REST client instance, yield it as async context manager from we talked before the break about it, and do something. You see, test which has our REST client, database connection. We create a new post using our REST client API and use database to check if a post is added to database. If you have no server, maybe server is in separate GitHub repository, separate project. You have no access to server code. You cannot start server. There is a way. See, in this example, we create an application, add only one endpoint, only one handler, and in handler, we do implement fake server. Just check that this endpoint was called with good for us values, test values. You see two assertions. And return some fake data and check data back. It looks like mocking, but it is not. It's better than mocking. Why? Because you create a real server and you test more moving parts. You send request and get response using network protocols, using a real network system. It's a little better than just monkey patching something and check how your monkey patch works. HTTP. HTTP is, HTTPS, secured HTTP, is a little tricky to test because you need a certificate. And you can order a certificate for test, but the problem is, again, certificate is coupled with DNS name. You have to start it properly, and probably it fails unless you deploy on production server. Not very handy to test HTTPS on my local laptop without DNS name coupled to this. But Nathaniel Smith authored a very good Trust Me library, and thanks to Svetlov to adopting it to Aiohttp tests. So the idea is, instead of using root certification authority from your operation system for test only, we create own temporary root certification authority. We issue a certificate for local host for testing only, just for time of running this program, or for a specific test, actually, in this case. We configure server SSL context and client SSL context, and this context can be passed into Aiohttp or Async I, or technically context can be passed to sockets, to requests library, by the way. And you have two pairs, two secured contexts, which can be used to create HTTPS connection. And both parts knows each other. So it's the most convenient way to test HTTPS, if you want. The last part, if you still want to or have to need to use mocking, there is a IO response which mocks a session. It hugs internal representation, and you can say, well, if you go to example.com, then return test body with 200 status. Looks pretty easy. I don't like it, but sometimes it can be handy. So it's very brief review of testing. If you're familiar with PyTest, with testing, I believe you get the idea how to work with tests in Aiohttp and asynchronous world. If not, sorry, the testing was a separate tutorial, 3 hours long, maybe. Maybe not enough. But anyway, I finished questions. Well, yes, looks like everything is clear, right?
No. Well, thank you, Andrew. It's great.
Thank you, Mariatta.
Thank you all for coming.